Good future, everyone. We humans made great advances in science, and we continue to do so. Better yet, we can do it faster if we would eliminate bad assumption about the direction of force. And here, for example, the assumption would be, here the two magnets here, and now that interaction there, often called the attraction force. Attraction, that means this pull and not this, or the pulling force, that means this pull on this to get itself together. And that is the bad assumption, because if mechanically we cannot, our person cannot construct a force that is able to move object that is via pulling or attraction. And I got the experiment here, which will scientifically show as a direct evidence. Scientific would mean that anyone can perform it and verify and get the same result. What you see here is a horizontal bar, pivot or balanced by this string. And that this line here, the reference line, and the two arrows of midline here. The force when the object moves from this to this direction here, if the force from the front half, let's say, is, and we can, common sense, we can refer to that as a pulling or attraction, but that point we can discuss, because not really, because that force doesn't exist. But however, here, if the force would come from this end, and we'll pull along this line. If I would pull forward here along this line, pull down here, to pull down for this to be close to this line here, what happened is this end is going to point up because restricted by the hanging string here. If the force goes toward here, and that's what it looks like. Now, we go on the other direction. If the force comes from the back half and go along this line here, so it's pushing, what will happen there? As you can see, when we go forward like that, this end point up. So for the object moving that direction, when the force is pushing from this end here, that go up. I'm going to stabilize it so it doesn't move everywhere. Now this is a magnet balanced on a string here, similar to, smaller scale, about 1/10 of the size of this bar, suspended in a pivot. So if when this move magnet this way, if the force is from this side, or pulling or attraction, then it will go up like so. When they go along this line, when the magnet, the force from here, then this go up. However, if the force pushing from the back end, this end going to go up. This right here go up. Alright? So I'm going to move in a magnet. Going to be, this is the center line here. It goes strong magnet, so it moves quickly. But you can see the front end lift up because the force is pushing from the back. Okay, let's do it again. One more time, and then I think you will see the it's clearly that the force. This is more of a general force and calculation wise. I mean, so in general, in this case, the force is from the back pushing. This experiment also would work for electric field, but you have to use a point charge in this case, and which one can conduct in the lab. This is now to apply the concept. The force direction is only push. Here this is an applied scenario. We have two parallel magnets here, same pole point this way, and you have this pole attract here. So now, as far as the current physics would say that if these two and this is opposite here, they will attract. Now we'll let go. That again, it clearly is repelled here. So the current physics cannot explain how a pull turns into a push here, unless you invent some nonsensical reasoning for it. Now for the if the force is only pushing, in this case, well, over here we can say it's a push, and when over here it's a push from this end in, and this equilibrium pushing both end here, so that's why it's right there. You can go to the other video called magnet interaction. In depth, I will show the vector field calculation for why it behaves like so. A push here, and why it push over here, and why it equal here. In that video, also going to explain, of course, in this the primary explain. In general, I mean, for simplistic case of two magnets, in this case, I mean, they push together, and also the vector field for it, and also the vector field for push apart. What happened there? So, if we use force correctly, direction is only push for things to be fit together. We could improve, also understand better how molecular chemistry wise, how it's structured, configured. similarly for biology, and also the cosmos. There are other videos about the motion theory will explain how an object moves. We'll go into detail what inertia and what is momentum and what is acceleration, and the detail of exactly how the force is to be only push only, because in a field you cannot construct any way to pull. Thanks for watching.